So this lesson will be Chapter 18, Lesson D, which is on integration is the title. But before I do Section D, I wanted to revisit the properties on Section C, page 452. And the reason is I just brushed over them so quickly last time. Page 452, the props of definite integrals. And in the homework on that same section, they had asked you to prove some of them, if I recall correctly, using fundamental theorem of calculus. But I wanted to talk about them just graphically, a few of them. The first one, the integral from a to a of f of x dx, you probably looked at that already and realized that there is no area under the curve from a to a. So that's why that would equal 0. And then the integral from a to b of c dx, and I can't recall if I went over this yet or not, so bear with me if I already did. But on a graph, xy, if you're going, so you're integrating from a to b, and c is a constant, so that means it's a horizontal line through y equals c. And when we're finding this integral, we're trying to find the area under the curve from a to b underneath c. And so obviously that's a rectangle, and the area of that rectangle would be length times width, or b minus a times the height, c. And so that's one way to look at that integral. Then another property of interest is the integral. Now they write it a little differently than I would have, but anyway, they write it from b to a of f of x dx is the opposite of the integral from a to b f of x dx. And I'll explain graphically why that is. So this first one, I don't really like the way they wrote this, but anyway, they're going from b to a. The way I'm just going to tell you the way I prefer to write it. I prefer to write it the integral from a to b of f of x dx is the opposite of the integral from b to a of f of x dx. So put the negative on the other side. Anyway, because I'm going to start with this integral from a to b of f of x. So let's just say f of x is up here. Here's a to b. And if you're finding that integral, that's going to give you this area underneath the curve, which would be a positive value. But then, if you go from b to a, then if you were making those rectangles, the widths of your rectangles would be the opposite. If you were going from b to a, than what they would be if you were going from a to b. The heights are still the same, but the widths are opposite in sign, so you would be getting, your integral would be the opposite of the original integral. So that's why they are opposite of each other. And then, I'll just mention this one. The integral from a to b of c f of x dx is the same as you could pull that constant out front. Just like we did with differentiation, we could pull a constant out front. We could do that with integration as well. And I think I did mention this last one, the integral from a to b of f of x dx plus the integral from b to c of f of x dx is the integral from a to c of f of x dx. And that was because, say here's f, here's a, b, c. So the first integral from a to b would give you this area. The second interval from b to c would give you this area. And that's equivalent to an integral from a to c. So that's the property. And then the last property there is pretty much common sense. So now let's do Section D, integration. So now I really am doing Section D. Okay, so let's see what we got here. The indefinite integral, so what I'm working up towards is this little definition that they have there. And So consider x squared, and you want to say you wanted to find the indefinite integral of x squared. So indefinite integrals are a family of functions whose derivative in this case would be x squared. So the family of functions whose integral is, or derivative is x squared would be x cubed over 3 plus c. So that's the indefinite integral of x squared. So in other words, the integral, you could write it like that. Now we have in the book, okay, so they have this statement here. This is actually an indefinite integral. It doesn't really label it that way, but that's what it is. Indefinite integral is if big F, if f prime of big F of x is little f of x. So in other words, the derivative of the antiderivative just gives you f of x. Then the integral, whoops, it's supposed to be f there. The integral of f of x dx is the antiderivative f of x plus c. So that's a definition for indefinite integral. Sorry, I have a cold still. And what else was I going to do here? Okay, example 5. Which says, if y equals x to the 4th plus 2x cubed, find dy dx. So that's the first thing they're asking us to find. Okay, well we can do that. We know how to differentiate. So dy dx would be the derivative, so 4x to the 3rd plus 6x squared. Now, using that result, it says, hence, find the integral of 2x cubed plus 3x squared dx. Okay, so what we're going to be doing then is we're going to, on these particular problems, and this is peculiar to the IB, the AP doesn't do these this way. In the AP, we would just go ahead and integrate that and get our answer. But the IB wants us to do it this way. So we found the derivative. Now what I'm going to do is I'm going to turn right around. So with this derivative that you just found, turn right around and integrate it. So I'm going to write the integral of 4x cubed plus 6x squared dx would therefore be what I started with, the y. X to the 4th plus 2x cubed. And since it's indefinite, we need a plus c. So this is how you're going to do this particular type of problem that the IB is asking you to do. You're going to start by differentiating, and then you're going to turn right back around and integrate what you just differentiated, and that's going to give you what you started with. So that's a very important step. Then you're going to go to, what is it asking you to find? It's asking you to find this. Well, you might notice that here, if I was to factor out the 2 here, I would get that integrand over there. So I'm going to go ahead and do that. And I'm going to factor out my 2 and put it out in front of the integral, because that's what we can do. So I'm taking a 2 out. Okay, so now this integrand matches what we're trying to find. And I also know all I did on this left-hand side here is I just factored a 2 out. So this whole thing is still equal to x to the 4th plus 2x cubed plus c. All I've done is manipulated the left-hand side, but it's still the same equation. So now they're asking us to find just this part here, so of course we're going to divide by 2 to both sides of the equation. So the integral that they're asking us to find is going to equal this right here. And you can go ahead and simplify it if you want. Actually, let's do that because we can do that. So x to the 4th over 2. Then on the next one, the 2's will cancel. And then the last one is c over 2. Well, c is an arbitrary constant, so it could be any number. So if I have c over 2, that's going to be in another number, but it's still just any number c. So you could just write it as plus c. You don't need to write it as c over 2. And voila, that one's done. Section D is actually quite short. We just had the one example, and guess what? There's one more, and then we're done. So this is short and sweet. And on these, I suppose, you could integrate them by hand using the properties and check your work and see if you get the right answer. But please do these the way the IB is asking us to do them. Because my guess is they're going to have you do these on the exam, so you need to know how to do it the way they're asking. So again, they're giving us y, and then they're asking for the derivative. Okay, so I'll go ahead and differentiate that. So we have it to the 1/2, so we'll pull the 1/2 out front. 1/2 minus 1 is negative 1/2 times the derivative of 5x minus 1, which is 5. I like to rewrite that a little, so I've got a 5 on top, a 2 on bottom, and then the root 5x minus 1 is down there on bottom. So I've differentiated. Now I'm going to turn right back around and integrate it. Of course, I guess I should probably tell you what we're doing on part B. So this was part A, and then part B is hence find the integral of 1 over the square root of 5x minus 1 dx. So that's our goal. Okay, so what you're going to do, as soon as you find the derivative, you're going to turn right back around and integrate it. I've got my 5/2. I like to pull that out. I just like my constants out in front. So I'm turning right back around and I'm integrating it. And I know that that integral is the y that I started with, plus c. Okay, so that's a standard procedure on these types of problems. Differentiate, turn right back around and integrate, and the integral is going to be the y that you started with, plus c. Then, look at what you're trying to find. In this case, they want us to find just the integral of dx over the square root of 5x minus 1. So they want us to just find that. Well, that's really easy, because all I have to do is get rid of the 5/2 by multiplying both sides by the reciprocal. So the integral of 1 over the square root of 5x minus 1 dx is going to be 2/5 times the square root of 5x minus 1. And I can just write plus c here, because if I multiply 2/5 times this c, I'm going to get another c. And that is just exactly what we got there. So that concludes the lesson. I hope you guys enjoy the homework.